So in C, we have a quadratic in the denominator that's not factorable, and this one doesn't actually have any zeros. So if we put in the discriminant, we get a negative discriminant. Now we can rearrange this into an inverse trig function or an inverse trig type. And so it's going to look like this. So we're going to make a perfect square because we have in the trig function, we can use arctan. Arctan uses that form. So if I can generate a perfect square plus a perfect square, then we can use an inverse arctan or the inverse tan to do this. So it looks like this. So I'm going to group together my x terms. So I end up with x squared plus 4x. I end up with 20. And maybe I'm just going to need a little bit more space here. So I end up with 20. And I'm going to complete the square. So I end up with plus 4. And then this becomes minus 4 to balance that off. And I'm going to group that together. And then I have times dx. Now, what ends up happening when I put that back together is I end up with 16 plus, and I end up with a perfect square over here. And by ending up with a perfect square over here, I now have a squared plus squared. And in fact, this 16 happens to be a perfect square, but I can express it as some root squared to make it a perfect square. So once I have this, I can apply my tan formula. Okay, so the antiderivative of this type uses arctan. So it looks like this, arctan. Okay, we end up with 1 over 4. Okay, that comes from the square root of that, ends up there. And then I end up with the x value is not x squared, but x plus 2 squared. So that ends up in the numerator. And then I end up with 4 in the denominator. And again, that 4 comes from that square root of 16. So the antiderivative looks like this. And so that works out to be, since it's an indefinite integral, I'm going to use plus c.